got an issue with the machine that I have to take care of. My son and I was working on it and inadvertently had broke that hinge. We've gotten our piece of metal milled for our hinge. I'm setting up a vacuum plate so that I can run that part on my handy lathe. Okay, well, I'm not sure how much of the lathe work you got. I'm trying to put together a fixture plate so that I can mount that hinge on the lathe and drill it out and ream it out. And so I've got the plate pretty much is round. I've got it scored in a circular pattern. Now I'm going to score it across at 90-degree angles, so I have kind of a reference spot. I've already centered it on the milling machine. I've got my bit set up, and I'm going to go ahead and we'll start milling this. But what I'll do, I'll bring up the camera so you can see the setup on the machine real quick. All we're doing is taking about 1/8 of an inch kerf out of this and to mark it. If I'd had a smaller tip, I'd take that, but I don't have any smaller than 1/8. So we're going to take 1/8 of an inch and do that. So anyway, I'm going to bring you up. I'm going to grab the camera and show you what I'm doing, and we'll go from there. So this is the fixture plate. And so I'm not sure if you got to see this whole thing or not, but I basically, this was a 1-inch piece of steel that I'd gotten. It was scrap, square. It was about 12 inches square. Now it's about 9.5 inches in circumference. And what I've done after I cut it on the lathe and faced it off, I've scored all these marks, so it helps me to center something if I'm going to be using it. We're going to be taking and drilling each hole on every 1/8 of the entire circumference. So every 45 degrees I'll be drilling holes on every one of those lines, and then we'll be tapping those holes and to make this a fixture plate that we can mount on our lathe and use it for mounting oddball sizes and that sort of thing. So that's what I'm doing with this. That's what the plan is. And once I get it done, then I'll be able to proceed with the hinge that I was building. So what I've got now is, you can't hardly see it, but it's a little teeny 1/8 inch tip in here. And I'm just going to score this across both directions. And then I'm going to run across this way as well, and so that we have a reference mark for center, and that'll just help me a little bit when I'm doing setups. And then we'll start drilling holes. So I'm going to put you back and we'll go to work. I want to make sure that I'm set on 0 on my table. Yep, table's on 0. I've got it tightened. Now I'm going to take this down. I don't think I need to score it too much, so we'll probably take a 1/1000th since it's such a small bit. And I'm going to be doing both a climb-in cut and a standard cut because I've got that centered right now. So we'll go ahead and we'll turn on our machine, check the oil, make sure she's pumping up there to the head. There we go. Reservoir looks good. Okay, now I'm going to crank her up about maybe 2/1000ths of an inch. And let's see if that little bit will hold up to that. It'll take us a little bit to get out to where we're going to start cutting. And I'll have to feed it real easy then, because that's just a teeny bit. There we go. I may have to bring her up a little bit more. She's hardly cutting. Let's bring her up just a tad bit more. See what we've got. 4/1000ths of an inch. Thought I had that zeroed out right. Yeah, we're still not scoring it. I'm going to bring it up another 4/1000ths. See what happens. Now we're starting to cut. Okay, you can see the score line. Let's see if I can right along here. And I think that's all the deeper I'm going to take her. I'll take and stone the face after I'm done. I'm down at 0.0440, and so I'm going to take it back up to 0 and then cut the other side across and take it down just as deep. I was taking about 0.08 of an inch at a time. I'm being ginger with this because I don't want to break this little teeny tip. I'm not used to using those. I used them on aluminum, and that's fine, but this is a little bit harder, and I just don't want to bust the thing. So at any rate, we'll take it at 0.08 per pass and take her down to 440 on the other side. So I'll bring you back when we get done and before we turn it. Okay, this is my last pass on this unit. We'll have that scored all the way across, then we'll turn the plate 180 degrees and put another marker. Okay, so you can see the score. We got the scoring all the way across. Now I just have to do one at 180 degrees and we'll be good. So I'll bring you back after I get set up. Okay, we're going to start running again across this face. I'm not going to put any cutting fluid on it. We're going to, so I can see it. Okay, so we've got our score across here and across here. So that helps me with determining location when I'm mounting something to the plate. Now we'll go ahead and we'll change heads on the machine and we'll start drilling. Then we'll take it over to the drill press and we'll drill it all out. I'm going to put a starter drill in it and drill it, and then come back and drill it on the drill press. That'll be easier than doing it on this machine. This doesn't have a head that has a spindle that moves up and down, so I have to raise the bed every time. That makes it pretty difficult, so I'd rather take it to the drill press. So that's what we'll do once we lay it out. I want to apologize for that video. I missed a lot of the action in my camera work. I apologize for that. I'm trying to get better at that, and we'll try to do better as we move along. But I missed a lot of the detailed work that I was doing. The bore out, bored out about a 1/15/16 hole in this, and you didn't get to see that. I goofed up the camera or something. I'm not sure what I did. And then I scored my fixture plate and a few other things that we didn't get onto the video. So I'm really sorry about that. What I'll do tonight is kind of bring you forward and show you the fixture plate, how far we've gone with it. I did make a mistake on it. I was drilling it out and I broke some countersink tips in it. I was trying to do a starter hole and the carbide tip busted on that thing, and so that's kind of a bummer. I'll have to try to dig that out or whatever. But I've got a tooling on the way. I've purchased some short bits that are designed to drill an accurate first hole without drifting. I forget what they call them. Forgive me, I should have written that down, but I did not. But at any rate, what I'll be able to do without drilling a pilot hole, I'll be able to use these drill bits, and they'll go right down through here. They're designed to carry the chip out, keep a nice round hole as they drill through, and then I'll be able to tap right after that. So anyway, those are coming. I've ordered those from MasterCar, and they'll be here. And once we get those, then we'll continue our drilling on this. But let me bring you forward. I'll show you this plate and what we've done so far, and then you can see what my thoughts are about this fixture plate and how we're going to use it to mount that part that we're going to be drilling on the lathe. So let me bring you forward here and I'll show you what we got going. So this is our fixture plate here, and as you see, I've drilled this out. This is an 1 15/16 hole, and what I did, I scored on the lathe while I had it in, and I put in a tool, and I scored these various little marks on here. And these will provide me with reference when I'm setting the part onto the plate, so I can help center the part where I want it. And I also created these cross hairs, you could say. That'll also give me some reference point. You can see where I've, this hole here is where I have a piece of carbide buried down in there. And so I'm going to have to dig that out. And hopefully I'll still be able to use the hole. So anyway, what the idea is we're going to have these holes at 45 degrees, and we'll offset the holes. So I'll have this set of holes running down through here, and then the next 45 degree turn, then we'll offset them differently. So we may have a hole down on this edge, skip the one that hole's on, and move on to the next all the way down to here. So, and then alternate on the next one, and that pattern will follow all the way across the plate. And anyway, it should give me a great deal of ability to fasten my work to this plate. It's a thick plate. It's about 7/8 of an inch thick, and the point that I'm going to use it for is to put parts into the lathe to do lathe work. Parts that are not round, and so this fixture plate will help me to use the lathe to prep parts that perhaps I want to drill a hole through or what have you, that or do some sort of milling on it, some feature on the part, so I can fasten this down and get it positioned wherever I want to accomplish the work that I want to do. So that's kind of what this plate's all about, and so we hope to get this finished up soon, and then we'll move forward on doing the hinge replacement. So as on a past video I showed where I had a broken hinge, and that hinge mounts right up here on my, oh boy, my Ajax lathe. So that ties into this pin here, and so what that'll enable me to do is to dismount this, and it just folds back over and it locks into this part here. And then I can pull my head out and mount my horizontal boring bars, and or if I wanted to put, I have another head down here. Let me take you down to show it. Oops. Okay, I want to take you and show you this head here. This kind of works. You can use this for okay, back with you again. So what this really is here is a slotting head. So I can move the other head off the machine, and then I can install this slotting head, and that can operate similar to a shaper in ways. This moves up and down, and you can adjust the length of the stroke, and so you could do inside keyways, outside keyways with it. You could do a lot of various types of things with these different tool holders that are on it, and putting different tools in it to make different shapes. But anyway, that's what this head does. And this thing probably weighs 150, 200 pounds in itself. To move this thing, we need to lift it with our hoist, because it's too much for a man to lift, or for this man, for me to lift. I'm not going to do it. I'm getting too old for that stuff. So this head here, the head that's on this thing, is about 200 pounds or better, maybe 250. It's massive. If you see me next to this machine, which you have, this machine is about another 3 to 4 inches taller than I am. I'm 5'10". So that tells you the height and size of this monster. And this head is just massive. So it'll be nice to get that hinge on there, get this thing fixed, and so it'll make it an easier job of pulling this head out and putting it back on. Now, when I pulled it off before to do those gears, coming off wasn't too awfully bad, but trying to get that thing back on again, right where it was supposed to be, was kind of a headache. So anyway, we'll get back to you. We're going to be doing some more milling with this thing later on, and I'll get back to you as that develops. Well, we're back at the milling machine here. We've had a few minor problems. In drilling, I broke off a couple of carbide tips into my fixture plate, so that's going to cause me a little bit of problems, but what I decided to do is just drill what I could on the plate and then move forward from there. I'll have to figure out how I can pull those out and then re-drill it. But I'm going to take you on in. We're going to be showing what we're doing here and start our drilling on this plate. So, what you didn't see on the lathe video, apparently I dropped a lot of the video on that one, so I'm really sorry about that. But we used the lathe to score this into circles. About every half inch I've got one from the center out, a line, and then we scored it across this way and this way with the milling machine at 180 degree angles, or 90 degree angles actually, so that we have reference marks. Then we're going to be drilling between each one of these lines, about every other line, and about every 45 degrees. So that's what we're up to, and we're going to make this so that we can use this as a fixture plate to put on the lathe, and put parts on the lathe to turn them for shaping or for drilling or what have you. So we're going to go ahead and we're going to get started here. This stuff is hard. Not cutting at all. Not cutting that. There we go. Now we're getting a chip. That's what I wanted to see. Okay, so we've gotten the plate drilled. I'm going to pull you off and bring you up a little bit closer to it. And so, let's see. There we go. Standard size. So this is what we're going to use as a fixture plate. I'll tap every one of these holes here, and then I'll be able to fasten anything I want onto this and put it onto the lathe. And so this being round, it'll fit in the jaws, and so I'll be able to use this as a fixture plate to run things within the lathe. So anyway, that's what I've put together. I just have to tap all those holes out, and I'll be good. Okay, well, we're in the welding shop, and I forgot to turn on the camera, but what we're doing is we're just chamfering all these holes real quick before we proceed with our tapping. So just going through with a countersink here and just getting all the garbage off of it. This is the back side. I've already done the front side. Looks like I pretty much got them. So now we'll flip this over, and I'll probably put it up on a bench. We'll start tapping this out. I'll bring you back when I get set up. We go through the whole thing without breaking a tap. You got every hole drilled 3/8/16. So we're good. Well, so the next thing is to mount something on here to show you what it's used for. And we'll do that probably tomorrow night. Hello there again. Well, we've pretty much finished up our fixture plate. And I'm going to still make some little clamps that I'm going to fasten to it. I want some adjustable clamps, so whatever I put onto it, I can add force from the sides or the tops or wherever I want to bolt that clamp to. And it'll be self-adjusting, so it'll come inwards from each side. I can put one clamp on one side, one clamp on the other side, and by adjusting an Allen screw, it'll push inwards on that from both sides. To keep it, that way I can adjust it from side to side, up and down, to get it exactly where I want it before I tighten all my bindings down on it. So at any rate, I've got a sample, in fact I got the block that I was making the hinge out of in the fixture plate on the lathe now. Now it's not a good setup, but for an example it's not bad. And what it's going to do is show us what that plate will do for us, that fixture plate, how it works and how it will hold that part, although it's not round, on the lathe. So let's go ahead and we'll take a look real quick. Okay, so this is the fixture plate on the lathe, the old Hindi, 1922 Hindi lathe. And what I've got is I've got the plate itself is chucked into the jaws, and then I've gotten my block of steel, which is a rectangular block. It's bolted onto the fixture plate. Now, I'm not fond of what I'm using here. These are just 3/8 standard bolts. I want to get some hardened bolts that I'll use with this fixture plate. These have way too much flex in them for my desires. Although with this fastened between the two ends like it is, it's down there pretty solid. It's not going to spin out of there. But anyway, it's really nice. I can, with the circles on this, I can position the plate so that it's equal in the center of those circles to get a close setup. And then, like I'm saying, what I want to do is be able to have a clamp that I can bolt in here that will have motion on the side of these that'll push it this way, maybe one on this side, one at the top and one at the bottom. Something that can adjust that in and out until I hit the center that I want. And then I can tighten all my binding down and it'll be ready to go. Right now, if you're just trying to hold it up there, it makes it kind of cumbersome. So anyway, let's go ahead and we'll turn her on. This is, oops, spin you around my shop here. Okay, so we got her set up there. And you can see she's holding real nice, doing a nice spin here. So that was the whole idea behind this fixture plate, is to get be able to fasten a square peg into a round hole, basically, and that's what we achieved. So, if you like the content of E.D.S. Inc. Shandon, then please subscribe. Enjoy us and enjoy the adventure with us. We have some diverse things that we do here. Maybe not as exciting as some programs, but I think you'll enjoy some of what we're doing as we build up our little shop here. And the other thing is too, you know, on Steve Summers' program, he did a shout out for aluminum. We still have a lot of stock. If it was light enough, I'd take you out and I'd show it to you. And maybe in my next video, I'll try to get out there during the daylight hours. It's inside a building, but I don't have lights in there, and or good light anyway. So it'd be pretty hard to see, I think. So what we'll do is once I have some daylight, and if I can get out there during the middle of the day, during work day, or on a weekend, I'll get out there and I'll video what I picked up, and if you want to have any of it, then let us know and we'll get it shipped out to you. So thanks for watching E.D.S. Inc. Thanks for joining us, and please watch our next episode too.
You brought a friend with you. It doesn't matter.
Listen, I think this was all just some big misunderstanding.
Was it a misunderstanding when you broke me? Not even your pathetic friend can. What? But how? No, this is impossible!
It's not impossible with an aluminum mech suit.
You think you've won? You're not the only one that ordered aluminum.
He's an aluminum robot decoy. If this is a decoy, then where's the real evil milling machine?
Yes.